let's finish simplex method. Two-phase simplex method. When we are gonna need two-phase simplex method, we need this method when we cannot find a canonical form of a simplex linear programming problem. So, for example, if fx is, we would like to minimize this simplex, this LP problem subject to this constant. So we would like to solve this LP problem. There are two equality constraints with 5 variables. So the basic set should have 2 variables. The coefficient of basic variable, for example, if x1 is x1 and x2 are basic variables, we shouldn't see the x2 in this equation and x1 in this equation. So as you see, it's not a good combination to have x1 and x2 as a basic variable. So you cannot find any other sets for basic variable to satisfy the canonical form. So for these types of the problem, we apply a two-phase simplex method. In phase 1, we determine whether there is a feasible basic solution exists, and if exists, we can start from that solution and apply the simplex method that we have learned in previous classes to get the optimum point. So let's see how phase 1 is working. I'm gonna back to this example to solve when I'm done with the two-phase simplex method. So, so for example, we have f equals to c1 x1 plus c2 x2 cn xn subject to a1 1x1 plus a1 2x2 a1 n xn equals to b1. So a21 x1 plus a22 x2 a2n xn equals to b2 an1 x1 so the general form of LP, something like this. Example for this. Here you have 2 equality constraints and the number of variables are 5. So to apply the first phase of simplex method, we introduce artificial variable. Y1 to it should be n. y1 to yn, and all of them are positive. So we have m equality constraint. We want to start the first phase. So to start the first phase, we introduce artificial variables of y1 to yn. With the same number of constraints, we have the same number of artificial variables. And we add them here. So when I'm going to solve this example, instead of y1 and y2, I may add x6 and x7. It doesn't matter what it would be. I just used y because I want to show the difference between these variables that I defined and the design variables that we already have in the problem. And we define another thing w, which is going to be equals to y1 plus y2 plus yn, summation of these artificial variables. We define that as a y, as w. So if I want to change it to the canonical form, I move f to the other side, it's going to be negative f equals to 0, and I move this to the other side, and it's going to be 0, something like this. So let me rewrite this again. A1 1x1 plus A1 x2 plus A1 and xn plus y1 equals to b1. A2 1x1 plus A2 x2 A2 and xn plus y2 equals to b2. am1 x1 am2 x2 these are the constraints, and we have c1 x1 plus c2 x2 cn xn minus f equals to 0. So for this one, what I'm gonna do, I'm gonna add this m equation. So if I add them up, I will get a11 plus a12 a1m x1 plus a21 a12 a12 plus a22 plus a2m x2 plus summation of them a1n plus a2n plus a m one, two, 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 M2 and Mn. Xn plus summation of them, y1 plus y2 plus ym equals to b1 plus b2 plus bn. Good? I just add them up. M equation, the coefficient of x1 is here, a11, a21, up to am1. coefficient of x2 is a12, a22 up to am2. And I have this summation right here, and the right hand side will be the summation of the b. Now I subtract this from this. So 0, this minus this minus this. So this, there is no x1 here, so I'm gonna leave this here. Let me define this as a the let me define a variable. di would be a1i plus a2i plus mi. So I define this as a summation of this. So for this one it's going to be d1. For this one is I will be 2. If I change I to 2, it's going to be a12, a22 plus all the way to am2. So this minus this, it's going to be d1 x1 plus d2 x2 all the way to dn xn. This minus this can be cancelled out by this can be cancelled out by this. So I'm going to get rid of y and plus w equals to this. Good. Let me just. I'm not going to change the major things. But I would like to deal with the negative w. So what I'm going to do, I'm going to define di as a negative of this. Negative. And I'm going to define w naught as a negative b1 plus b2 plus bn. Just defining intermediate value to simplify the notation. Now, if I multiply both sides by negative, what I will get is going to be d1 x1 plus d2 x2 all the way negative dn xn. Negative w equals to this is going to be w naught. I'm not going to change the objective function, so I'm going to leave it there. C1 x1 plus C2 x2 Cn xn minus f equals to. Can you tell me in this new set how many basic variables should I have? You said one. How many equations do we have?
2.
And plus this. I have this m plus this 2. It's going to be m plus 2. So I should have m plus 2 basic variables. What I did, I didn't touch the constraint just for this y, this w that I defined. here. I add them up all equality constraints and subtracted this from that summation, and I could end up to this. And I also kept the objective function here. So I have m plus 2. So m plus 2 equations. We said y1 to ym plus negative f and negative w as m plus 2 basic variables. Okay? Now look at this. In this equation, I have y1 showing up with the coefficient of 1, but there is no y2, ym, negative f, and negative w. So it can satisfy in the canonical form. This equation, y2 is showing up, but there is no y1 to ym, and no negative f and negative w. It's going to be valid for this. An objective function, there is no y1 to ym, and there is no negative w. We only have negative f. And in last equation, no y1 and to ym, no negative f, we only have negative w. So it's a canonical form. So now we apply the simplex method for this and find the optimum value. If w is greater than 0 at optimum point, then there is no feasible solution. We can terminate and say there is no possible solution for the original problem. If w is 0 or negative, we remove w from the system of equations and continue with the rest of value. Basically, when we get w 0 or negative at the optimum point, we can have that set of solution as a starting point or as a first basic feasible solution, and then just continue the standard simplex method. If I solve an example, it's going to be much more. Make sense? So the first phase is going to stop here when you find the optimum value for w. Second phase, by doing the first phase, we just want to determine if there is any feasible solution exists. If exists, then we apply the second phase, which is the same as standard simplex method. Okay, so I'm gonna work on this example by drawing the tableau over there and applying this one. So we can't find the first basic feasible solution. So what I'm gonna do, let me add y1 and y2 equals 2 plus y. Okay? So I'm not gonna touch the equality constraint because they're already in that format. But I need to form this d1x1 plus d2x2 up to d5x5 negative derivative. And I already have d1, d2, d3, and d5. So let me find d1. d1 is here. A1 1 plus A2 1 up to A. So I'm gonna add these two. 3 plus 1 and negative behind that. 3 plus 1. Negative 4. Following me? Because you have to do the same things on the homework. I'm adding them. D2 is negative of summation of these two. Negative 3 plus 1. Negative 3 plus 1, negative 2, negative times negative D2. D3, negative 4, plus 1, negative 5. D4, it's right here, 2 plus 3, negative 5, and D5 is negative 1 plus 1 is going to be 0. So my basis or basic variable would be y1 and y2.
Quick question.
Yes.
It's regarding the equation, the third equation. It used to have plus 2 over there. So
Oh yeah, thank you. I forgot.
That's what I was
Yeah. No, I erased that, but I forgot that. It should have. So y1 and y2 are my basic variables plus 2, negative f and negative w. I'm just drawing this line because I would like to separate the variables from the value of the objective function, although they are basic variables. So my basic variables or my bases are these 4. 1, 2, 3, 4. I have 4 equations, 4 basic. So my variables are x1, x2, x3, x4, x5, y1, and y2. Is second I for A second I S which are positive, we calculate B second I divided by A second I S. Alright, now let me fill out the first row. The coefficient of x1 is a11. It's 3, negative 3, 4, 2, negative 1, 1, and 0. And there is no B second is 0. Second equation is going to be 1, 1, 1, 3, 1, 0, 1. Make sure that I'm 6, 1, 1, 1, 3, 1, 0, 1. And for this equation, negative f, right here. F, if I move it to the other side, I will get 2. And 3, 2, negative 1, 1. There is no y showing up. And this equation is d1 is negative 4. I'm trying to get negative 4x1, negative plus 2x2, negative 5x3, negative 5x4, 0x5, negative w equals to negative 2. W naught is b1 plus b2, these 2. 0 plus 2 is going to be 2. The right hand side should be, if w is going to be negative 2. Yeah. So the coefficient of x1 here is negative 4, 2, negative 5, negative 5, 0, 0, 0, negative 2, and f is 0. Okay?
For the y2, is there nothing for the di? Or is there minus 2?
It should be 2. I forgot. It should be. I mean, whatever is the right hand side, it should go there.
Quick question. Y1 and Y2, what would that be? Just the Y1 and
y1 and y2.
or just the 1 and 0, 1? Would it be
Yes.
anything
On
different?
the first equation, what is the coefficient of y1?
Yeah, that's just 1.
1 and no y2 shown up. If you look at the basic variable, if there's only one of them should show up on each equation. Here y1 is showing up, y2 is 0. Here y2 is showing up, y1 is 0. And we don't have any f and w showing up on the first equation and second equation. Why did we switch to the two-phase simplex? Because we couldn't find something like that. Make sense? Now, here, find the most negative coefficient that variable, either this one or this one, they have most negative. You look at the negative derivative, not the f. Either x3 or x4 should be moved in. So I pick x4. You can pick this one, x3. Now, here, the coefficient b second is 0. 0 divided by 2 is going to be 0. 2 divided by 3 is going to be 2 over 10. Comparing 0 and 2 over 10, this is smaller, so we take this row, we go from this way, so the pivot variable will be 2. I'm done with this first iteration. Second iteration, I'm gonna remove y1 and add x4, replace it with x4. Make sense? This is the variable that it should come in to the basic. Which variable should be moved out? I'm gonna look at this. I'm gonna divide b second by the coefficient of a second IAS, this one, if it's positive, which is the case. I will get 0 here. For this one, I divide 2 by third, I will get 2 over third. Compare them and go with the variable, with the value which is smaller. So I'll go with this row. If I go this way and I go this way, I'll end up to this way. Okay? So next iteration is going to be x4. I keep y2 here. Negative f and negative derivative is going to be there. So the coefficients of the basic variable is x4 and y2. The coefficient of x4 should be 1. So I divide everything by 2 on the first row. 3 over 10, negative 3 over 2, 4 divided by 2, 2, 1, negative 1 over 2, 1 over 2, 0, 0. Second row, I don't touch it for y2, but I should get rid of 3. Okay, I shouldn't see 3 on the second row under column of x4 because x4 shouldn't show up here. Right now is 3. Make sense?
So all these coefficients are y1 divided by negative f1?
No, here you mean?
Yeah.
The coefficient of x4 is 2,
Yep.
but it should be 1.
Oh, okay. So
I divided all coefficient by 1, by 2, sorry, on the first equation. You can divide both sides of the equation by any coefficient which is non-zero. Why did I do that? Because the coefficient of basic variable should be 1 in each row. And the coefficient of other basic variable must be 0. Okay? So now, to second row, I should get rid of these 3. I subtract, I multiply this by 3 to make this 3. I subtract 3 of this from this, okay? Just one by one. 1 minus 3 times 3 over 2, okay? Why do I do that? Because if I multiply 3, subtract 3 from 3, I will get 0. This is my goal. So 1 minus 9 over 2 is going to be 2 minus 9 over 2, negative 7 over 2. Negative 7 over 2. Okay. I multiply this by 3, 1 minus this. 1 minus
8 over 2? Where'd you get the 2?
1 minus 9 over 2. It's going to be 2 minus 9 over 2. Which one do you have?
I guess just because I think like 1 minus 3 over 2, wouldn't it would just be 1 minus.
I multiply this by 3.
Oh, I think I got what
You got it? So, and then this minus this.
Yep.
So 1 minus 3 times 3. It's going to be 1 plus 9 over 2, 11 over 2. So it's going to be positive 11. 1 minus 6, negative 5. Okay? 3 minus 3, 0. 1 minus over 1 over 2. 1 minus 3 times 1 over 2. 3 over 2, positive 3 over 2, 5 over 2. And this 0 minus 3 over 2. It's going to be negative 3 over 2. 1 minus 3 times this is going to be 1. And 2 minus 3 times 0 is going to be 2. Okay? Make sense? Make sure that you, because in homework and exam, if you get stuck and you make some mistake, you are not gonna end up to the right solution. I can't wait until you can figure out our coefficients. The key point is here. In the new iteration, we look at the basic variable, which are x4 and y2. The coefficient of x4 in this row must be 1. The coefficient of y2 in this row must be 0. If it's not, you have to do some manipulation you should manipulate the equation such that you will get this, satisfy this condition. So here, the coefficient of x4 is not 1, I divided by 2. I end up to this. The coefficient of y2 should be 0, it's already 0. No worry about it. But second equation, the coefficient of x4 should be 0, which is not. So what I did, I multiplied this by 3, I subtracted this from this.
Can we only use x4 and y, x4 for that, or like can we use any other equation to make that 3 0?
No, you should use x4.
Just x4, right?
Yes, we are dealing with the basic variable.
Okay.
Make sense?
Yeah.
And here the coefficient of y2 is 1, coefficient of x4 we made it 0. And in negative f, see, there is no y1 and y2. y1 and y2 have the coefficient of 0. Now, in this set, the coefficient of x4 and y2 should be 0. But here I have x4. How can I get rid of that? This is negative 1, this is 1. If I add them up, so this plus this, 2 plus 3 over 2, okay? 7 over 2. Negative 3 over 2 plus 3, 6 minus 3, 3 over 2, okay? 2 plus 2, 4. Negative 1 plus 1, 0. 1 plus negative 1 over 2, 1 over 2. And 0 plus 1 over 2, 1 over 2. 0 plus 0, 0. And 0 plus 0 is going to be 0. Make sense? So there is no x4 in negative f. In negative w, I shouldn't have any value for y1 and y2 on the first iteration, but on second iteration, x4 and y2 shouldn't have any coefficient. y2 doesn't have any coefficient, but x4 has. x4 has the coefficient of 5. So I'm going to multiply this by 5, add to this. Make sense? 5 times this. So for this one, I'm just writing 5 times rho of x4 plus negative w. The row of x4, 5, it's going to be 15 divided by 2 minus 4. Okay, 15 divided by 2 minus 4, it's going to be 15 minus 8 divided by 2, 7 over 2. 5 times this, negative 15 divided by 2 plus 2 plus 2. 2 times 2 is going to be 4, negative 11 divided by 2. negative 5 plus 10 is going to be positive 5. 5 times this is going to be 5. I already made it 0. Negative 5 over 2, 0. Negative 5 over 2, then negative 5 over 2. 5 over 2 plus 0. Yeah, it's 0, it's 0. If I multiply by 5, this one plus this is going to be 0. What else? Multiply this, negative 2 is going to get negative 2. 5 times 0 plus negative 2, I will get negative 2. Okay, any question so far? Can you see how we get this coefficient? Alright. Now we are done with second iteration. On this row, I'm looking for the mass negative coefficient. This is negative 5.5, this is negative 2.5. So I'll go with this. So if I go up, x2 is going to be the next variable coming in to the basis. Which variable should go out? The coefficient of this one. The coefficient of this is negative, so I don't deal with this. Okay? Because it's negative. I'll deal with this one. And since for azagon is greater than 0, we have to calculate this. But this is not positive here. Make sense? The only positive is coming from second row. So it's kind of, I don't need to do that because there are 2 rows. I don't calculate this. It's going to tell me I have to go with this row, and this one is going to be my pivot. But if you like, we can just divide this by this one. 2 divided by 11 over 2. 4 over 11. Make sense? So the next row that I'm gonna draw here have the set of x4, x3, x4 and x3, x2, x4 and x2, y2 is going out, x2 should be replaced by x4 and x3. Here x1, x2, x3, x4, x1, y0, sorry, y1, y2. Alright, first row, I would like to write the first row. The coefficient of x4 and x3 should be 1. The coefficient of x2 is not 1. Sorry, what did I? I should start from this row. The coefficient of x4 and x2, one of them should show up, which is x2. The other one should have the coefficient of 0, which is the case. But this one should be 1. The coefficient of x2 should be 1. x2, y3. Make sense? So I'm going to divide both sides by our coefficient by 2 divided by 11. 2 divided by 11 for this is going to be 1. So negative negative 7 over 2 divided by 11 over 2 is going to be negative 7 over 11. This coefficient, negative 5 divided by 11 over 2. Negative 5 divided by 11 over 2. Negative 10 over 11. x4. x4 is 0. 0 divided by 11 over 2 is going to be 0. 5 over 2 divided by 11 over 2, it's going to be 5 divided by 11. Negative 3 over 2 divided by 11 over 2, it's going to be negative 3 over 11. 1 divided by 11 over 2, it's going to be 2 divided by 11. And 2 divided by 11 over 2, it's going to be 4 divided by 11. So I was going to make a mistake. You have to start with the row that you remove the basic variable. So you cannot start from this row. You have to start with this row first. Make it 1. I made it 1. Then look at this row. The coefficient of x2 should be 0 and coefficient of x4 should be 1. It's already 1, but I should make it 0. Make sense? Right now the coefficient of x2 here is this. If I multiply this by 3 over 2 and add with this one, so 3 over 2 times row x2 plus row x4. It's gonna give me 0 here. Make sense? This is 1. Look at this. This is 1. 3 times over 2 times 1 is going to be 1.5. 1.5 plus negative 1.5 is going to be 0.
Why couldn't we use the row minus f on it?
This one?
Yeah.
You have to use the row that you remove the variable from that. Make sense?
Okay.
Then you should deal with this to make it in a canonical form. We are going to reach that point, but always we call it pivot. So when we are talking about pivot, you have to deal with this row. So negative 7 3 over 2 times negative 7 over 11 plus 3 over 2. Negative 21 over 22 plus 33 divided by 22. 33 minus 21, it's going to be 12 divided by 22 or 6 divided by 11. So this coefficient is going to be 6 divided by 11. So if I do the same thing for this, I just skip the steps. If you want, I can do that. Let me do that. 3 over 2 times. It's better that you write what you are going to do, then continue follow that rule. So 3 over 2 times negative 10 over 11 plus rho x4. Rho x4 has the coefficient of 2. Negative 15 over 11 plus 22 over 11. 7 over 11. 7 over 11. I already have this. 0. I have 0 here. Multiplied by 3 over 2 is going to be 0, plus 1 is going to be 1. Three over 2 multiplied by 5 over 11 plus negative 1 over 2, yes, negative 1 over 2. It's going to be 15 divided by 22, negative 11 divided by 22. 15 minus 11, 4, divided by 22, it's going to be 2 divided by 11. Uh, 3 over 2 times negative 3 over 11 plus 1 over 2. Negative 9 over 22 plus 11 over 22. 1 over 11. And y2 is gonna be 3 over 2 times 2 over 11 plus 0. It's gonna be 3 over 11. And B second is gonna be 3 over 2 times 4 over 11 plus 0. It's 6 over 11. Okay. Now let's deal with the negative f. Negative f shouldn't have x4 and x2. It doesn't have x4, but it has x2, 3 over 2. Three over 2 times 3 over 2 times x2 minus the negative f, negative this. Negative f has coefficient of 3 over 2 minus 3 over 2. I'm going to get 0 here. So it's going to be 0. Let me count on this. Negative f has 7 over 2 minus 3 over 2. Let me put it there. This minus f. It doesn't matter, but x2 is negative 7 over 11 minus 7 over 2. So it's going to be negative 21 divided by 22, negative 77 divided by 22. The other way is better. 98 divided by 22, or 49 divided by 11, positive 49. So it doesn't matter if you said this minus this or this minus this. So this subtracted from this, this subtracted from this. Since I'm gonna check the coefficient here. This is the way that I do. Negative f, this coefficient, minus 1.5 times x2. It's going to give me 0 here. Here I have coefficient of 4, minus 1, minus 3 over 2, multiplied by negative 10 over 11. 44 divided by 11 plus 15 divided by 11. 59 divided by 11. X4 and both are 0. I will get 0 here. X5 is this guy, 1 over 2. So the coefficient of that is negative 1 over 2, or positive 1 over 2, minus 3 over 2 times rho x2, which is 5 over 11. It's going to give me negative 4 divided by, negative 2 divided by 11. Y1 has the coefficient of 1 over 2 minus 3 over 2 times negative 3 over 11. It's going to be 11 over 22 plus 9 over 22, 5 over 11. And 10 over 11. 20 divided, yes, 10 over 11. And y2 is going to be coefficient has 0 minus 3 over 2 times 2 over 11. Negative 3 over 11. Right side is 0. Over 11, negative 6 over 11. And this row has negative 11 over 2 for x2, but it should be 0. I multiply 11 over 2 times row x2 plus row negative 7. So 11 over 2 times this. Plus 7 over 2. Look at this. It's going to be negative 7 over 2 plus 7 over 2. It's going to be 0. X2 is going to be 0 because I already multiplied that with that coefficient. A negative 11 over 2 times negative 10 over 11 plus 5. Negative 10 divided by 2, negative 5 plus 5 is going to be 0. If you do this, for this one, you will get 0, 0, 0, 0, and 0. Now, we can stop here because, for the phase 1, because there is no negative sign here, and the value of the omega is 0. It's telling me that we have a basis, we have a basic feasible solution. What is the basic feasible solution? x4 equals to 6 over 11, x2 is 4 over 11. Now I can start phase 2, but we are going to drop these 2 columns. These 2, they are not going to show up anymore.
What BI? Wilson.
Pardon?
The last column, BI.
Yeah, we should keep it.
Okay.
We should keep it because this is the value of our basic variables on the first iteration of phase 2 of Simplex. Let me write it down. The basic variable are x4 and x2. The coefficients are 6 over 11. I'm just writing them. 0, 7 over 11, 1, 2 over 11. We don't deal with this. And the value of the x4 is 6 over 11. Second row is negative 7 over 11, 1, negative 10 over 11, 0, 5 over 1. We don't deal with this anymore. And this guy is 4 over 11. And negative f is 49 divided by 11, 0, 59, 11, 0, negative 2 over 11. And the objective function is negative 6 over 11. Now look at the last row. Which variable should be selected? X5. Now we go with this one. The coefficient of x5 here is positive. So I divide 611 by 211. I will get 3. Here, 6 divided by 2, I cancel out 11. It's going to be 3. So 411 divided by 511 is going to be 4 over 5. The smallest should be pick 3 versus 4 over 5. I'll pick this row, go this way. I will use this cell as a pivot. Make sense? I don't continue this, I'm just writing the final answer. What you need to do, you need to, on the next iteration, you need to divide this whole, the entire of the row by 5 by 11. You will get 1 here, 0, whatever is the coefficient here, negative 2, negative 7 over 5. 4/5, and then continue. But I'm writing the final answer, x4, the optimal value would be 4/5, x5 would be 2/5, x1 and x2, x3 is 0. The minimum value of objective function is 2/5. If in the first phase we could get the positive value for W, we should say there is no possible solution. This simplex, this LP problem doesn't have any feasible solution. But if you get 0 or negative, then you can go to the second phase by knowing that if you just rewrite this 2 row, it's going to be your initial point, initial feasible point, then continue to optimize the problem. Good? Yep. So today it's officially our last lecture. We don't have any class on Monday because if I start the new topic, it's going to take at least 2 weeks.
Are you going to be here Monday?
In my office.
Just so that way we can maybe look at our presentations.
Sure.
If that works. Also, I have a article if you want to peek into it and see if that would work.
Okay.
I highlighted what I think should be important stuff. You might not have the right number of constraints because they kind of go through and they do like the initial study and then they
And what is because I don't see any nonlinear what is the W up next? Is there any function for that? Right here.
yeah, I think that's like
So it's going to use this equation for the W up.
Mhm.
So if this is the case, yes, you can. Because I thought, first when I looked, I thought there is no non-linearity in the problem. And where is the objective function? G. Yep. Go for it. Right. Now it's time to just go for every column and then how to set up that function. So we have presentation on Monday after the Thanksgiving. It shouldn't exceed 15 minutes. 15 maximum.
For the presentation, should we like just talk about what we did, like our code, or should it be like, do we actually do like a summary of their report and then our code on top of that?
Yeah. What I want to see is
Do you have an example of previous presentation that somebody made?
since there is I'm not getting any report from my students. I don't have any sample because I should get a report from them. Then I'll give you an sample. But what I'm asking you guys to for the 15 minutes, I would like to see you talk about this paper is going to model this. Okay, and to model this, this is the objective function and constraint that they have used. Talk about, just briefly, talk about the objective function and constraint, also talk about the design variables. In this objective function, they would like to optimize this based on this design variable. Just briefly talk about the design variables that they use. Then maybe in the last 5 or 4 minutes, you just bring your results. Say, okay, this is the result that they generated, they reported. I use the fmin_con. I can see. You are gonna send me the code at the end, but you can just make a snapshot of the code and the result that you generated over there. I think that's all. And it shouldn't exceed 15 minutes.
And then all you want, so then you're probably gonna want the presentation after we're done, and then our code.
Yes, your code and the paper that you have.
And
Because then when I run the code, I can see the results matching with the
code, paper we use, and our presentation.
yes. So consider 12 minutes presentation and 2-3 minutes for questions. So you are 3, it should be done in less than an hour.